Hi everyone, I'm Aaron Runk, and today what we're going to be doing is using our new Vericut software. This software is designed to take your part programs and check them to a model within your stock. So that way we can tell if our tool path and our tool setup will make a good part before we even get out to the machine. So let's get started. First thing we're going to do when we open up our software is it's going to bring up this screen with some tutorials and a lot to select from. So it'll have a list of previously worked on projects, but we're going to go into new inch projects. So I'm going to click on that and it'll bring us to this blank screen where we can go from there. Now, we're going to go through and set up the majority of these settings so that we can see how our toolpath will look on our program. So let's pay attention. On control and machine, when you get the software, you may have been given a library of control files and machine files. Well, I have a couple of them set off to the side so we can get through this quickly. I'm going to hit control and I can right click on it to open up a new one, or I can go to here to open up a new one. So I'll click down here. When this opens up, I have put mine on the desktop. So I'm going to go to my desktop. It's on my Vericut. And then I'm going to go to my control files and my machine files. So right here, I'll click on control. I have a Fanuc 30i, and it puts it right in there. Same thing. I will right click on this one and go to open. And I'll do the same thing. I'll go to my desktop, go to Vericut. I'll go to machine and I'll click on here. Now a second ago I double clicked on it. You can click on it once and hit open and it will do the same thing. And now I have a generic 3-axis mill. So we have that out of the way. I'm going to click on fixture. I'm not going to import a fixture right now. That's where I would put a vise into my simulation, but I'm just going to focus on the stock and the design. So on my stock, I'm going to have this print right here that I'm going to show you. So right here it says my material is 4 inches by 4 inch. Now I have a part program that I think will make this part correctly. That's what we're going to verify. So I'm going to go set up my material for this right here. I'm going to go into stock. I'm going to come down here and I'm going to scroll down. I want to make sure under visibility it has both views. I'll come under model and I'm going to make a block. But right here, if you look, it's real small, so I'm going to zoom up on my block and then I'm going to give it 4 inches, tab, and then I'll give it 0.5 and I'll hit enter. I'll click off of it and you'll see that it brings in that color. Now get used to your controls. So my right click will move it around, left click and hold will rotate it. Those are your main functions right there, and of course scrolling up and down work that way as well. If you click and hold the middle mouse, it's going to scroll way up on that little view and your part's going to be lost. If that happens, we're going to right click, we're going to go to here to fit everything right there. Very good. So what I like to do is I like to make this translucent, so I'm going to right click on the material. I'm going to go to stock, appearance, and right here under translucent, you can scale it however you want it. I usually go 0.5 and hit enter. And then I will hit close. So from here, I've got my model brought in. I have the stock selected and so on and so forth. Now we can go further in depth on the stock material type and stuff like that. But for right now, I just want to see if my program will make a good part. So the next thing I'm going to do is I want to bring in my model. Now this model that I'm bringing in is a model that I created in SolidWorks. Now I saved it as a different type of file and I'll show you that in just a moment. So I'm going to click on design. I want to make sure it's visible in both views. It will default to invisible so you can keep bringing it in, but it won't show up. So I'm going to go to add model. I'm going to go model file, and then I'm going to go find that model file. Now I have put mine on the desktop under Vericut, and I have it in my 8M folder. Now, if you'll notice, this is a parasolid that I saved it in. Now, a lot of times, different files will work. You have to figure out which one your Vericut likes to use. So I'm going to click on that and hit OK. And if you'll notice, it came in, but it came in at the wrong orientation. Now, this has everything to do with how you modeled it in the other software, the SolidWorks. But not to worry, we're going to rotate it, and I'll show you how. So with that highlighted, I'm going to go to Rotate. I'm going to rotate it by 90 degrees, but I'm going to figure out which way. So I'm going to click on Z first. That wasn't it, so I can come back and undo it. Is it going to be Y? It's not Y, so I can undo it. I'll hit X plus. That's what we're looking for. So I'm going to go ahead and leave that there. So something I want to look at is I'm going to bring my program in over here, and I can see that my header says that the material is 4 inches by 4 inches by 1/2 inch thick. It tells me where the XY0 is. But what I'm looking for is this right here. This is going to affect me at this location right now. So my program is going to be shifted from the bottom left corner a positive 30 in X and in Y. So I need to move my model inside the material those distances for it to be correct. So I'm going to pull this out of the way, and I'm going to go into Translate. Now, Translate is going to look a little weird. I'm going to click up here because I want to move it an incremental amount, but I'm going to move it in the negative. I'm going to hit space. I'm going to do negative again. That represents the Y, and this represents the X. I'll space again for Z. I don't want to move it in Z, so I'll simply put a 0. So when I hit move, if you watch it very carefully, you'll see that it did move. Now notice the base of my part exceeds the model. So I'll show you something here in just a little bit on how to fix that. But what I'm looking for is for my part profile to be within the box, because I am only cutting the part profile in my program. So now I'm going to click off of it. I'm going to rotate it back up and center it. The next thing I want to do is I want to start making my coordinate system. So this is all done. I will simply minimize that portion of my program. I'm going to go into my coordinate system, and I'm going to add a new one. Now this is called a CSIS. You'll hear someone use that terminology. It's a coordinate system. So I'm going to add a new one, and then I'm going to go to Translate. It's going to default to a location on your part, but I want to put it in a certain location. I want to put it at the bottom left corner of my part, and Z0 is going to be the top of my part right here. So I'm going to translate it all at one time. So I'm going to come down here to Translate, and I'm going to position it at a vertex. I'm going to click on the arrow, and it wants me to pick it. Now you see my arrow jumping around. I can put it wherever, but I'm going to scroll up right here. Now I don't want to put it at the bottom left. I want to put it at the bottom left of my model. So you see I highlight it, and with it in this position I left click, and it does the rest for me. That works out very well. So now, this is where it's kind of confusing, but this has to happen. I'm going to rename it. This will help. G54. All my programs will need a G-code offset that will align itself with the CSIS that we just created. So under here, I'm going to name this G54, and I want to put my coordinate system in line with my G-code offset. So I will click on CSIS number 1, and I will simply hit Add. You will see that this coordinate system is in line with CSIS number 1. But I wanted to rename it, and it didn't work. And I'll tell you why. When I go to rename, I type in G54, I must hit Enter. Once I do it, you'll see those two correct themselves. So that works out really good. So we have this set up, but there's one extra step. On my part, I have an origin right here, but when I programmed my pocket, because I hand programmed it, I programmed it as if the center of my pocket was XY0. That's not a problem. So I will minimize this. We'll go back up to my coordinate system, and I'm going to add a new one. Again, I will come down here to vertex. I'm going to put it in the same location as the other one. You'll notice that it has that 30,000 shift, just like the shift I made on my model. So I'm going to rename this one G55 and hit enter. Now remember, if your program has a G55, this will work. If you have programmed your entire part using G54, I would not have to build the additional CSIS. So now I have to translate this to the center of my pocket. So if I pull up my print, you'll see that I have to move the X 1 inch 377 thousandths over. I'll have to move the Y 2 inches 755 thousandths up, and then I will translate it. Minus 1 inch 377 thousandths. I'll hit space for my Y coordinate. Minus 2 inches 755 thousandths, space, and then I'm going to put a 0 because I don't want to move it in Z. Now I'm using this as a negative because it's moving it that direction. If you do it as a positive, it will end up over here, in which case you can simply hit back and try again. So I'm going to hit move, and you can see that it moves up there. And keep in mind, now that I've created a CSIS, if my program is using a G55 work offset, I have to create a new one, and we'll call it G55. And I'll be using the G55 CSIS for my location. You'll see it shows it right there. And then I'll hit add. So that all looks really good. We are actually moving pretty fast. So I'm going to go ahead and minimize my coordinate system and my G-code offsets. Now we're going to go into our tooling. This is where we're going to need to pull up my program to see what tools I have here. So I have a 3-inch face mill, a 1/2 inch end mill with a 0 radius. I have a number 3 center drill and a 1/4 inch drill. So we're going to build these 4 tools, and if you'll notice, they're labeled 1, 3, 6, and 8. Now what's important is in your program, what are they labeled? So this is labeled 1, and then it's labeled 2, and then my center drill is actually 3, and that's 4. So I can update it right here, no problem. 2, 3, 4. Just in case you want it for visual reference. But what's important is what the program's calling up. It's calling up G54 and then a T and an H. So I'll hit save so that it keeps my changes. And then let's go ahead and build these tools. So I'm going to go into tooling, and I'm going to head tool library. Well, I don't have one built, so I can't load one. But if I had one built, I could simply go through and click on it. So we're going to build one, so I'm going to double click, and it's going to bring up my tool manager. So in here we have a lot of options to do things, but we don't want to spend a lot of time. We're trying to get this done. So I'm going to go into mill because I want to make a milling tool. And then I'm going to go through and simply add some variables. So we said our first tool is going to be a 3-inch end mill. And I'm going to make the shank 2 inches just so it looks the same size as my holder. And then there's no radius on the end of it. So therefore I won't use this as anything else except for a flat bottom end mill. But if I had a radius, I could click on it. If I had a tapered bowl nose or if I had a bull nose, I could simply go through and add all these functions. So right here, that looks good. I have carbide inserts, so I'll leave this as carbide. When I click off of it, it will keep my settings. So I'm going to come up here to default, and I'm going to rename this a 3-inch face mill. And the thing that's important is the first tool you make, the 1 and the driven point 1 will match. However, when we make our next tool, we need to make sure that those tools match, or else it will not work correctly in our simulation. Now, holder, you have the options of making just a generic holder, or if you have a DXF file that you can import of a holder, you can bring that in as well, or you can simply build one in the graphics window. Well, we're not going to go that far right now. We're just going to simply minimize tool number 1 because we're happy with what we have. So my next tool, as you can see, is a 1/2 inch end mill. So I'm going to click mill. The default setting was a 1/2 inch, and it has a 0 radius. So this actually came in exactly how we needed it. So I'll simply click on here and see how it says default tool. We notice it didn't take in my value because I forgot to hit enter. So 3 inches, face mill, and I have to hit enter. So we'll do the same thing right here. I will come up to here and it will be a 1/2 inch high-speed steel end mill, and I'll hit enter. But notice my first tool was carbide. This one's going to be high-speed steel. So I'll come back to my cutter. I will come down here to the cutter material and change to high-speed steel, and I will hit enter. So before we close this out, remember I want my 2 and my ID to match. So think of it as this is the T number, this is the H number. I want them to match. So I'm going to click right here. I'll click one more time, 2, enter. And then that way it will look correctly in my simulation. The next thing I want to do is I want to make a hole. So I'm going to make a center drill using hole making. The cutter will come up and it will have these options for a drill, a reamer, a center drill, or a tap. Well, we're going to use a center drill, and I believe the default size is a number 4, but my hole diameter is an 1/8, so I can't do that. So a number 3 center drill has an 1/8 inch diameter, so I'll type that in and push enter. And you'll notice that my graphics changed. So as well on the diameter, I believe it's a 3/8 diameter, so I simply type it in and hit enter. And if you need to extend this tool out of the holder or retract it, you can control it with these graphics right here. Now again, this is a center drill, which is high-speed steel. I'm going to go to cutter material and select high-speed steel. I'll come back up to my holder. I'll type in number 3 center drill and hit enter, and then my ID number has to match my tool number. So 3, enter, and then I'll simply close it. We're almost done. We have one more tool to make. I'll go into hole making. I will come up here to drill. I'm going to type in an 1/8 of an inch and hit enter, and I'll just leave it just like that. It's really long, but it's okay. So I'll come back up to my cutter material, high-speed steel. If you have a carbide drill, you can just leave it as carbide or a ceramic or cobalt. So I'll come up here to description, and we're going to call this an 1/8 inch drill, and I'll hit enter, and I want my 4 to match my ID. So I'll click down here and type in 4 and enter. So this is really good. This is all done. Now before I close this, I need to save it so that if my software decides to crash, I know where that's at. So I'm just going to do a generic save. I'm just going to save under downloads. It saves it as a TLS, and I'll call it 8M. And then I'll just click over here and hit save. So this works out good. So I'm going to hit exit. And now I've got my tooling. Now that's going to take you the majority of the time is just building your tools. So here's where it gets pretty easy. All I need is my program. So on my program, I'm going to go to add program files. Now mine is going to be under Vericut, under the 8M, under that text document. So this text document that we're grabbing is this one right here. So I'll hit OK. And it came in right there. So if I double click, you'll see that everything did come in just as it shows here. So I'm going to exit that. Now right here, if I hit play, it's going to go really fast. So I'm going to slow it down just a little bit, and it will still go pretty fast. And I'm going to hit play. Now is where we want to see if our program is going to work. So I'll hit play. And I see some things already that don't look right. So I have all these islands right here. Now my program, if you'll notice, it uses cutter comp. So I have to make sure that my software over here is set up to use cutter comp. So I'm going to hit eject real quick. I do want to reset the simulation. I'm going to go under setup. Under G code, it says cutter comp is off. So I'm going to click the drop down menu and then I'm going to go to default to full radius. And I will click OK. Because we hand programmed it, we have our cutter comp. This will allow cutter comp to work. I will simply hit play again, or I like to hit eject just because. I'm going to hit play again and see what it does. Very cool. So it took into consideration what my cutter comp was. So looking at this, it looks to be right. It's cutting on the front of my part. It's cutting on the side of my part, and that's the reason why I put the 30 thousandths in there. So if you look right here, this is what my part should look like when it's done. Now if I had not shifted my 30 thousandths when I run this on the machine, it would look like this. It would not have any cleanup. So I definitely want this to show, which is exactly what it shows right here. So that's good. Now the last thing I got to do to make sure that nothing is out of tolerance to the model is I'm going to go up here. Then I'm going to come up to my auto defer, and it's going to give me my options. So right now, if it is gouging into the model by more than 4 thousandths, it will show up red. If it has excess material more than 4 thousandths, it will show up blue. With the majority of my tolerances being plus or minus 5, I like to keep it just a little bit lower, but if we needed to, we could simply change it right there, hit apply. Now I'm going to hit compare. Now if you notice, I got some weird things going on right here. So when I look at this, I've got red on the top, I've got red on the side, I've got red on the top of the part, and at the bottom of my holes. So this is why it's always good to run in Vericut before we take it out to the machine, because it may look good in a 2.5D simulator, but we want to see everything as it compares to our model. So I'm going to look at my program and see what's happening. So Z0 will tackle the biggest part first. It's supposed to be the top of my part. So when I look at my program, Z0 is the top of my part, which means my face mill should be going across the part at Z0. So if I scroll down, you'll see my face mill. There it is. It's actually going down 10 thousandths instead of being at Z0 like it's supposed to. So I'll move this out of the way. I'll cancel this for just a moment. I'm going to go ahead and hit eject and look at my part. Now right here, I'm going to look over here and I'm going to see that I have that right there. And I'm going to simply type in a 0 and I'm going to save it. I'm going to close it and we're going to do nothing but rerun it. You can see that it comes up here, it completes my pockets, holes look good. I'm simply going to go up to compare this time because we already have the settings set. So I'll hit compare and you can see the face of my part is correct now. That looks good. But I got a couple other things going on here. I've got a little move right here that I don't like. And I have this excess material that isn't being cut, but it's being left. So it feels like it's cutting it because it's not within the model. Well, that's easy. I'm going to come back up here to my machine. I'm going to go into my attachments. I'm going to go back into my stock. Now remember, I'm going to hit eject to kind of help us get back out of that simulation. So right here, I'm going to click open to here and go into my models. Now my block is 4 inches by 4 inches, but remember my model has been moved. So if you wanted to make it look better, just visually pleasing, we're going to have to go into our model and we're going to have to make it a little bit bigger. So if I moved 30 thousandths, I will go ahead and move my block to be 30 thousandths bigger as well. I'll hit enter. So now my block matches my model, and I'm simply going to hit play again. And that's all we're doing right now, is we're just troubleshooting. So once this gets done drilling, I will come up to compare, and you will see that this looks pretty good. I've got that taken care of. I've got the blue on this side because it's still 30 thousandths heavy, which I'm not too worried about. If you needed to, we can move the model as well, but I'm not too worried about that right there. I'm more worried about my gouging that I have going on right here. Well, here's something cool. So what we're going to do is we're going to move that up, and you can see I've got a lot of information right here as to what it thinks is gouging and what tool it is. But if I look down here, I have 9 gouges, but I've got my first gouge happening at line 195. Now what I want to do is I want to open up my program, and I don't have N numbers, so it's kind of hard to find line 195. Well, that's what this little block search is for. I'm going to type in 195, and I'm going to search for that line because that's where my gouge is happening. So if you'll notice, right here I have a G40, but it's canceling while it's right next to the wall. So it's actually moving into the wall on this G40. So I'm simply going to type in an X0 because that's where I was when I started cutting the pocket. That's where I'm going to end when I turn off my cutter comp. I'll hit save. I'll exit this out. We'll go ahead and lower this back down, and I'll eject, and I'll simply hit play again. So you don't see it very much when it's running because it's hard to see. That's why the compare file shows us everything we need. That looks really good. So my tool, instead of canceling cutter comp right here next to the wall, it moved back to center while canceling and did not go into my wall right here. Now the last thing I got to look at, now this is going to be interesting. Every single one of these holes is going too deep. Now when you're modeling your parts, okay, if I scroll up, you'll notice it looks like the drill tip on each hole is what's going too deep. Now when I modeled this part, I'll show you, these holes do not have a drill tip angle on them. They are just a flat bottom hole, and they're programmed to the right depth, but because my drill has a drill point on it, that is what's exceeding my model, which is going to be just fine because if I look at my blueprint, if you'll notice, it wants my diameter of 1/8 of an inch to be that deep. So I have it modeled that deep, and my drill point has to go deeper so that the diameter of the drill is that deep. So this right here looks good. And if you wanted to fix it for visual purposes, I could simply go back into my tool library and tell it that that tool was an end mill, or I could say that there's a flat bottom drill. There's multiple ways you can do it, but ideally this is what you're looking for when you are all done. So once you have what you like, if you make an edit or need to come back to it for later, I'm going to go to File because we just did a lot. We don't want to lose anything that we just did. So I'm going to go to File. I'm going to go to Save As or Save All because it's the first time we did it. I like to go Save As. And I'm just going to put this in my downloads, or better yet, let's go put it in my Vericut. So I'm going to click on 8M. It's in my Vericut. It's in the 8M file, which had my program in it. I'll go ahead and name it 8M, and then I'll simply hit Save. And if you look up here at the top, my project is now saved as 8M. So if I ever want to come back and look at this, I can simply open that up, and everything that we just did is still there. All right, so with that, we have successfully gone through and we have set up our Vericut software to run our program over our stock and to verify our program is making a good part to our model. So the good news is Now that we've gone through and verified our program and everything looks good, we are now safe to go out to that machine and start setting it up, knowing that we have a good part program. So again, my name is Aaron Runk. I hope you all enjoyed this content. Be sure and like and subscribe for more, and good luck out there.